Okay, so just to reiterate what we talked about in the last video to just make sure we have everything correct, we were trying to calculate the slope of the curve at this particular x value, at this specific x value. So we drew a tangent line, right, to approximate the slope, because if we could figure out the slope of the tangent line, right, and again, I'm just going to make up a number. Let's say the slope was 1, then we know the slope at this particular point on the curve is 1. But we needed 2 points to calculate slope because that's our formula from Algebra 1. And we need the 2 points to be on the actual curve that we have so we can actually find their specific values to like plug into a formula. So we drew another point on the secant line. And when you calculate slope, it's y2, right, minus y1 over x2 minus x1. And we said the slope of the secant line is a really bad approximation of the slope of the tangent line. So to fix that problem and to make the slope calculation that we want much more accurate, instead of drawing the secant line to be, h units away from the first point or really far away, we thought, wouldn't it be a great idea to allow us to draw better secant lines, to allow this distance of h to slowly approach 0, not necessarily equal 0, but become infinitely close, arbitrarily close to 0. So close, in fact, that I still technically have 2 distinct points to calculate slope, but they're so close together that it's a really accurate calculation. So in the last video, we said, let's just draw better secant lines, right? Let's let the secant line little by little become closer and closer and get better and better as an approximation until eventually, and my drawings are horrible. I actually have a really good demonstration on the computer of this on GeoGebra in my Schoology page that you guys can see, because it'll be way better than me trying to draw this. But you kind of get the idea. As I keep drawing better and better secant lines, the slope of the secant line approaches the slope of the tangent line and becomes almost identical to it, such that the derivative is pretty accurate. Okay, so in the next video, I'm actually going to do a real life calculation of the derivative. Okay, so before we do that, really just make sure that you have the formula down and all the notation. Okay, so the derivative or the slope on a curve is indicated by f, looks like a prime of x, equals the limit as h approaches 0 of f of x plus h minus f of x over h. And that's just my slope formula, rise over run. And remember, the h came from x2 minus x1. x2 was x plus h. x1 was x, and when I subtracted them, the x's canceled. So that's why I just have the h there. So make sure you have that down, and we're going to do an actual calculation in the next video.